Okay, our next guest speaker is Suzanne Greene, and she's joining us from the MIT Center for Transportation and Logistics, and where she's responsible for sustainable supply chains, and her particular focus is on climate, so I know you'll have some interesting things to discuss with our visitors from Finland. And a fun fact about Suzanne is she was actually at Dr. Bronner's soap factory yesterday in San Diego, and when we spoke earlier, I actually thought that was some sort of amusement place for soap lovers. And before checking it out, now I realize they are an amazing example of sustainable energy. So welcome to the stage, Suzanne Greene. Thank you.
Great. Thank you so much for having me here today. Okay, so I'm based here at the MIT Center for Transportation and Logistics, and we are the home for supply chain management at MIT. So I brought 2 souvenirs from my trip to show you. So first is some chapstick from Dr. Bronner's, the hippie soap company. You might know them, I'm not sure. So I was visiting them because they really are masters of knowing their supply chain. So they're sourcing the most sustainable olive oil, coconut oil, palm oil from around the world. They're obsessed with fair trade and human rights and treating their farmers well. So they're really an amazing company. And what I've been helping them with is understanding their climate footprint. So they're really into fair trade, but their goods are coming from all around the world. So actually they do have a bit of a carbon footprint because none of their things are grown here in the US. So it's kind of relative how you think about sustainability. So the other thing I want to show you is something I picked up at HP this week. So I was also at HP in San Diego, and that's their home for 3D printing. So this is a 3D printed, I don't know what, cool thing. I can show you afterwards. And so what they're trying to do is they're integrating sustainability into their business model, really in all facets, from their manufacturing to really what they're making. So 3D printers, the idea here is to ship less things, so to be able to print things on site. So they're actually printing the parts for their printers with their 3D printers. And they have a contract now with Volkswagen to print replacement parts on site, so they don't have to ship from China or Vietnam or wherever their parts are coming from. But then kind of the funny thing about this is you could say, well, isn't plastic bad for the environment? And aren't we worried about ocean plastic? So that just shows you that what is sustainability can be really a complicated topic that has a lot of different aspects you need to consider. So I want to talk a little bit more about that today and show you what we've been working on at the center. And I have up here some of the many different things that I've worked on, and me and my colleagues have worked on at MIT, thinking about the carbon footprint of manufacturing, transportation, all things related to the supply chain. So I've worked on everything from servers, laptops, phones, to banana, you see there, metals and minerals, shoes, t-shirts, you name it. It's all kind of has the same, all these things have the same issues, which is kind of an interesting thing to think about. You might not think a banana has the same issue as a light bulb, but it kind of does in a way. So I want to walk you through kind of what that means and what we've seen, and maybe get you thinking about some aspects of the supply chain that maybe haven't considered, and some food for thought. So let's think about the banana. We all eat bananas all the time. Maybe people eat them every day, but we might not know exactly what goes into getting them here to us. So this is a study we did at the Center for Transportation and Logistics a while ago, about 8 years ago actually, with Chiquita banana. And they didn't know their carbon footprint at that time. So we've come a long way actually in the last 8 years that I've been working on this topic, that things that maybe are common now, they really didn't know back then. So what you can see here is that transportation actually makes up over a third of the carbon footprint of the banana. So this is a banana coming from Central America to Boston. And farming is the other third, the other major third. So that includes the fertilizers. A lot of the carbon footprint from farming is the fertilizers and pesticides that are needed to grow the banana. So if anyone were to venture a guess at what the carbon footprint of a single banana delivered to Boston might be in grams of carbon dioxide, does anyone have a wild guess? 2 grams? Okay, any other guesses? Who said 100? 118 grams of CO2. So what does that mean? Do we care? Is that good or bad? Do you have any sense of whether that's good or bad? Yeah, like we don't know. But banana has become kind of the metric for me. Like how many bananas does it take to get something to us? So, you have to decide, is this good or bad? I don't know. So let's think about it a little bit more. Here are some other products that we've done at MIT here that we've looked at. So we have the banana suddenly looking really good, right? Next to a tennis shoe, and then of course a laptop. Laptops have a lot of components, very complicated equipment, obviously. A lot of different manufacturers involved there. Pretty high carbon footprint. So that's the product carbon footprint. So that's the footprint for two shoes, one banana, one laptop. But let's think about the industry, the sector. So you have to think beyond just the product and how many of these things are manufactured each year. So now that you look at it this way, how does the banana look? It's not so good, is it? Yeah, so these things are quite complicated, and what might seem small as the sector is actually quite a large footprint. So I'm going to go through a few more things. A lot of my work these days is around 2 different sectors, the logistics sector and metals and minerals. So you might think, what do those 2 things have to do with each other? But they're both really actually quite interesting topics. Logistics touches everything we do, so I'm focusing really on transportation, so that everything we have is transported all around the globe. Transportation is supposed to triple. Freight transportation over the next 20 years. So we're going to see a huge rise in transportation. We have the Amazon effect, but also globalization, things traveling really long distances to get to different parts of the supply chain. And then metals and minerals, that's also a hugely growing sector. It's at the base of almost every supply chain, and it's something we're not always so connected with. And you could say the same thing about freight transportation. It's not necessarily something we interact with and see in our everyday activities. But there it is. It's crucial to everything we do. So let's just think a little bit about metals and minerals. So this is a study I did last year, looking at different companies, their carbon footprints. So these are, I'm not picking on any of these companies, but these are publicly disclosed carbon data from different mining companies. And so I have scope 1, 2, and 3. Scope 1 is their own operations, so their own facilities, vehicles, vessels, machinery. Scope 2 is the power that they buy. And scope 3 is their supply chain emissions. And so you can see Glencore, Rio, Vale, these are huge, absolutely huge companies, BHP. Almost all their impact is actually in their supply chain. So it's really quite a massive impact. So that's all their, a lot of their transportation, their purchased goods. When BHP mines iron ore, then they move it to China and it gets turned to steel. So that's all in their supply chain. So let's dig in a little bit. Potash. Potassium fertilizer, probably not something you're thinking about every day, but it's really an integral part of almost every agricultural supply chain in the world. So potassium is in everything we're eating. And it's mined primarily in northern regions. So a lot in Canada, Russia, little bit in Morocco, I think maybe even Finland. Jordan, okay. And you can see the primary importers of potassium fertilizer, potash, Brazil, India, and China. And so what you see here is it's really moving all around the globe by ship. So what does that mean in terms of the carbon footprint? If you were to go on one of the leading potash producers' website to look for the carbon footprint, if you're saying how many tons of CO2 per ton of potash, what's the intensity? If you were to look that up, you would see they would say it's 0.05 tons of CO2 per ton of potash. So that means you have to think this through. So if you want to just do a quick job, you can just Google it and look it up and grab the number, which is what a lot of us do that. But if you think about it a little bit further, that's when it leaves the factory in Saskatchewan, Canada. Okay, in this case. Again, I'm not picking on this company. It's just their publicly disclosed information. But what if you need to move this to Brazil, which is what is happening, right? What happens to the carbon footprint that isn't in the discussion typically? Okay, so this is rail. In this particular case, the potash goes on a rail journey from Saskatchewan to Vancouver, takes a ship to Brazil, drives about 1,000 kilometers to the agricultural region on a not so clean truck. Okay, so that's really what happens. So by the time it gets to the farm in Brazil, you can see the carbon footprint is very, very different from when it first left the factory. So this is something that I'm really encouraging all of us to think about, is what is this transportation footprint? And something that's happening here at MIT, actually, we have a professor of sustainable metallurgy, if you ever knew that was a thing, Professor Antoine Alenor. He's actually invented a new way of making potash that you can make it locally on site. And in Brazil, actually, in particular, these tropical soils, the potash from Canada actually doesn't work so well in tropical soil. So he's finding a new way to make it on site that would actually eliminate the majority of this carbon footprint. So food for thought, thinking about new ways to do things, breaking into new systems. Okay, so here's something more fun than fertilizer to think about, wine. This is a study that I did actually for a friend of mine that has a wine importing business here in New England. And what she hears a lot is, we need to buy wine from California. It's local. It's a local good. But what do you think? Do you think it's better or worse than wine from Italy, I'm going to say here? Yeah. It's worse. You would think, California, but it comes by truck. And it's actually a lot worse. So here we have the kilograms of CO2 per case of wine. To come from Italy, it goes by truck, gets on a ship, comes here to Boston. It's pretty low impact. The truck from California, it's not great. You can see it's very clear. It's much, much higher. So I'm challenging your views of what is a local product and what do we need to buy. So in Whole Foods, if you see the plum came from Argentina, you might think, I don't want to buy something all the way from Argentina. But if it's shipped by sea, then maybe you do. Okay, so what would happen if instead of the California wine going by truck, they waited 6 weeks to send it through the Panama Canal? Okay, so you order way ahead, you plan. There you go. So it's really, you can have your California wine. You just need to wait 6 weeks for it. So I want to just talk a little bit more about the logistics sector and how it interfaces with, us and the shippers, the cargo owners. So this is kind of what the lay of the land looks like with the sector. What happens is the shippers might say free 2-day shipping, free 1-day shipping, right, Amazon. But then, really, that's where it ends for the shipper. They push it down to their logistics service provider. So that's like your UPS, DHL, DB Schenker, Kuehne + Nagel. These are your middlemen that they might have some trucks and planes, but a lot of times they then subcontract to a world of other carriers around the globe. Very, very complicated system. There's something like 5 million trucks in the world, and the majority of trucking companies have 1 to 3 trucks. So we're talking about really, really small businesses around the world. A huge number of companies, changing all the time. A lot of times these deals between the logistics service provider and the truck driving company, they're done just on the phone, like, hey, can you pick this up? It's a really a fast-moving and constantly changing sector. And what that means a lot of the time is there's a bottleneck of information. So you can't, if you're a shipper, if you're HP, you don't always know what's happening. So you don't know how your stuff is going. And you don't even necessarily have control over that, right? So if HP is really dedicated to lowering their carbon footprint, but they can't say, I want to send my stuff on the good ship or the electric truck. They can maybe say that, but they don't know if it's happening. They don't really have a lot of control. So when it comes to HP's really progressive carbon targets, where they're trying to reduce their carbon footprint by quite a bit, and if they don't know how their stuff is traveling, it's really hard to know if they're meeting their targets. So that's what we're helping them with, is trying to connect all these dots and try to get there. So what really happens? How do we really track our progress towards our climate goals? You might think, oh, we're measuring, we're really looking, we're going to find this information, through our technology. But I hate to tell you that that's not really what happens. Okay, so on the left you see this satellite that's kind of beaming down. This is a Chinese satellite that's actually not working yet. So this is a very aspirational idea to really measure the carbon emissions. But what really happens is you estimate. It gets estimated from a distance. It's often very inaccurate. So you can see on the right, don't fall asleep, but these are 2 methodologies that I've written to help companies really measure or estimate their carbon footprint consistently. So what we're trying to do, one of my main missions, is to have everybody account for their carbon footprint the same way. So standardizing the way these emissions are calculated. So one truck driver does it the same as another truck driver, does it the same as DHL, does it the same as UPS. So that's what we're really trying to get together, is align everybody. And there I have good news that is actually working. And the GLEC framework there that's on the middle, that's probably the most widely used thing I've ever written. So it's very, very popular. It's my one hit song, if you were, but everybody says it's very boring and it's too long and too technical. But anyways, it's working. It's something that does work in practice, and it's something that MIT can really contribute, is these kind of neutral platforms. We'll tell you how to do things right. But since here we are thinking about the future, I have to say that the great hope is blockchain, right? That maybe will eliminate this need to estimate. So maybe you've talked about blockchain. I missed the last couple days of your conference. But what we see that is a really exciting potential in terms of sustainability is to really understand how your product got from A to B, And if we can see, if HP, for example, can see, what ship their things came on, what route it took, what kind of truck it took, where did it actually go? Blockchain has the potential to really break down that kind of barrier of knowledge that we see now and connect all the dots in a way that we just don't have. So I'm hoping to go out of business and let this take over. But I think it's going to be a while before that happens. So another thing we like to think about is tracing and tracking. Blockchain, we're really hoping for that here. So Here I'm showing you some conflict metals. At the top, tin, tantalum, tungsten, and gold. These are things that are in all of our IT products. They're mined materials. Again, an interesting disconnect between, our super high-tech world and mines in the Congo. And really just everyday people and children out there mining these things that are fueling our high-tech economy. So this is something I think is really important to connect with, where are these things actually coming from? I have cobalt on there. Cobalt is in our batteries. So lithium-ion batteries, electric vehicles, all these things we want to see happen in sustainability. Again, it's coming back to the mining sector. And then I have something that isn't labeled. Anyone have a guess what this is? It's clearly not a metal or mineral. No, but what did you? That's right, that's a palm kernel. So this is what Dr. Bronner's is trying to source sustainably, palm oil. This is, maybe you could call it a conflict oil. Okay, it's in a lot of soaps and foods that we eat. So your Kit Kat bar, your palm olive soap, palm oil. It's grown in Indonesia primarily, and it has a pretty bad reputation for deforestation, killing orangutans, things we don't like to see. So we're hoping that blockchain can help us see where our oils and minerals are coming from so we can make sure we're sourcing from the right places. Okay, so now I'm going to talk a little bit more about the maritime sector. So this is an area where I think we have a lot of potential to kind of demystify and understand our supply chains. So just a fun diagram looking at global trade lanes around the world. The ships are moving constantly around the world. There's about 5,000 container ships in the world compared to 5 million trucks. So actually, it's quite a more manageable thing to understand. I just wanted to point this out, just a little graphic to show something we're seeing is that more and more ships are able to go to the northern passage, the Arctic passageway, cutting off a lot of the kind of southern route there through Singapore and Indonesia, but going through the ice, or what's left of the ice. And why do we care about that? Okay, it'll trim off time, right, of shipments, but it's kind of bad news for the climate, right? Because you have these ships, they spew out a lot of this soot, and soot is filled with something called black carbon. And black carbon is both a climate pollutant and a human health issue. And another thing is that it lands on ice. And so you can see it here, this black stuff on the ice, that's the black carbon, and it melts ice. So it heats up the ice and it melts it. So this is just something that's on my mind that now I'm going to make you look at. That if all these ships are going up into these northern latitudes, what does that mean for climate change? Is this really a good plan for our ice? And this isn't just about the Arctic. This is also about the Himalayas. So we see the same thing with black carbon coming up out of Southeast Asia, South Asia, India, blowing up onto the Himalayas. You see the same type of black carbon on the glaciers there, melting the ice. Okay, so here's a study that I did for a company that is shipping a lot of goods from Asia to Europe. Okay, and so I looked at their shipping register, and I could see everything here. I could see what ships the stuff was going on. It was actually on their little shipment register because the customs, I guess you have to write what ship. So actually the shipper was quite surprised that this was in their data set, but there it was. So what you see here is the CO2 emissions by ship for about a year worth of shipments. And you can see this one particular ship, Sainar Sabang. Again, I don't have anything against the ship, but this is just an interesting thing that came out of the data, that about half their emissions was from one ship. So that really struck me, like what is going on with the ship. But what I saw was actually that ship wasn't carrying that much of their goods. So what is the story there? Why are the emissions so high? But the cool thing about the maritime industry is you can really find the ship. So I just Googled it, and there it is. When I Googled it the day, you could see exactly where it's sailing. Its current position, longitude, latitude. That's what it looks like. It got 1 vote, 4 out of 5 stars for this ship with 1 vote. I don't know what that means, but you know, again, I don't know anything about this ship really, but it's a dirty ship, okay? And it was really causing a lot of emissions for this company. So when I informed the company, hey, if you want to lower your emissions, get your stuff off that ship. And they called their logistics service provider, said, get my stuff off that ship. And these are the things you can do, right? And I'm not saying it's easy to get your stuff off the ship, but we need to ask these questions, okay? We can look at what's going on and see how we can make a change and, clean up our air quality and really, put our money on good things. So let's see. I'm going to talk a little bit here about these difficult to decarbonize modes. So air and maritime. So these are 2 modes that they're saying, we don't have the technology. We're not going to have an electric plane anytime soon or an electric ship. It's just we're not ready. So we're not going to be able to set the same types of climate goals as maybe the road sector or rail that can electrify more easily. So what they're saying is we're going to buy carbon offsets. Okay, so we're going to go plant trees somewhere because we can't do anything about it. And I am challenging this sector to do something a little bit different rather than, plant trees. So what we're thinking about here at the Center for Transportation and Logistics and my group, Sustainable Supply Chains, is investing this carbon offset back into the transportation sector. So here on the right, you see a very visual representation of black carbon. So here's that stuff that I keep talking about, the soot that is coming out of cars and trucks that we can reduce today. There's filters. Okay, there's retrofits you can put on old trucks. We can buy back old trucks and ships. We can buy the Sonar Sabang and take it off the sea, if we wanted to. These are things we really can do today and make a huge difference. So I'm really encouraging the industry to think about it this way and invest in itself to improve. I love tree plantings. I'm not anti-tree planting, but I think we need to move forward and push our own sectors forward. And I think as cargo owners, I'm not sure your role in the supply chain, but we all have a role that we can push forward and make these changes. Okay, so I'm going to leave it there.
Perfect timing.
All right.
Yes, well done. So
Thanks.
Thank you so much. That was very, very interesting.
Thank you.
I don't know, how many companies in the room have ever questioned and queried which ships their goods are being sent out on? Does anybody know? No, there's a no there. Yeah. I'm sure it's not a common thing. Yes, Hitesh? You have a question? Oh, a suggestion?
List of all such vessels and make them museums for what not to do.
The list exists. So actually, Richard Branson, maybe 5 years ago, he made a list of every ship. There's 5,000 ships. He listed them all. We know the bad guys, but they're still at sea. So
I think your point about putting money back in and buying them back, and maybe buy them back and plant trees on them, right, somewhere. Then you get the double whammy.
Thank you.
We've got time for one question, and then we're back on track, which is great. Okay, I know you've got a question. There's a question over here too. So can we take the question over there, and then Robin, you can have a question, given that you've worked so hard. You've earned one.
Yeah, mine is a non-technical question. slightly embarrassed that over half of the US population doesn't believe that climate change is real or caused by man. That has caused us politically to not address this issue. Has anybody at MIT thought about how to solve that problem? That's a much harder problem.
Oh, the climate deniers.
Yeah, exactly. How to convince people.
Yeah, you know, that's where I really like to talk about this black carbon. Because it's a human health issue. You know, we breathe it in, it's really bad for you. So trying to connect more with CO2 can be hard to talk about because it's this invisible gas. You know, but black carbon, we all have had a truck go by us, and, you know. So that's where I'm trying to reframe a little bit the argument around something that's a little more really tangible thing. But in terms of, you know, America and our role in all this, I find really most of the companies that I work with, they're not changing anything about their climate goals because of what Trump is saying. You know, they're international companies. All these companies are operating all over the world, and they still have to follow the way the world is going. So, yeah.
Just to add to that.
Can you wait for the microphone? Go on. Thank you.
We have largely seen wherever there's benefits involved, truth becomes a matter of consensus. Okay? We have a consensus on profit. We have a consensus on loss. But the truth, it might not be always profit, maybe usually loss. So arriving at a consensus where the facts and the figures continue to speak about themselves is a very difficult question. It's difficult to handle inside a small organization. Now we are talking about pan-global corporations, countries. I think it's more political than technological. I think politics will have to take the first stab at it.
Okay, good point. So was there one last question, then we're going to wrap up, because we're having a philosophical debate now, but we can continue over our tea and coffee. Any more questions? Okay, all right. Well, thank you to all this morning's speakers. Thank you. Oh, there was a question?
I had a question.
Okay, we're nearly closed. Go. Last one.
It's a very basic question. What I wanted to understand was buying a book from Amazon.com and shipping it versus buying a book from a Barnes & Noble at a local mall. Which is greener?
Is that controversial?
Yeah, I mean,
your local shop.
It completely depends on how it gets to you, right?
Yeah.
If UPS has their electric parcel truck bringing it to you, yeah, that's green. I mean, it just really depends on the vehicle and how it moves to you.
I've been struggling with this question for some time now.
Yeah.
So maybe you two can sit together at the break and you can figure out how to solve that one. All right, so thank you, everybody. We're now back on track. If you can be back in the room for 10:40, thank you, Suzanne, and all of our morning speakers.